All right, 3.6, we're going to take a look at analyzing arguments again, but from a different point of view. So instead of using Euler diagrams, the ones that look like the Venn diagrams from 3.5, we're going to use truth tables like we did back in sections 3.2 and 3.3, okay? The structural setup for this is going to look completely different, but it's going to lead us to same conclusions of is the argument going to be valid or invalid, okay? This one requires a bit more setup, all right? So the next slide's going to have a whole bunch of writing on it. I'm going to read through it briefly, and then I'm going to let you write it down, okay? This is how we test the validity of an argument with a truth table. The step number 1 is that we assign letters to represent the components of the argument. Step 2 is to express each premise and conclusion symbolically. Step 3 is to create a symbolic statement using an and statement, that's a conjunction of all the premises as the antecedent of a conditional statement and the conclusion as a consequent. Yeah, this is a smart sounding slide, isn't it? Oh yeah. And then step 4 is to create the truth table and decide if it's valid. It will be valid if it's a tautology. And tautologies showed up in section 3.3 that you hopefully watched a video for. Tautologies are when the ending column is all true. When the ending column is all true, it creates a tautology. That creates a valid argument. So please write all those steps down, and then we're going to do some examples. All right, it's a lot of writing. The processes for each of the steps aren't nearly as convoluted, especially step 3 sounds like really very wordy. The actual process for doing so isn't quite so strategically difficult. But what we're going to do is we're going to build up to actually accomplishing from step 1 down to step 4. So the first couple that we do are going to be sort of like given to us in the middle of the process because I want you to get the mechanics of it down and not just start to finish and see how all of it sort of fits together from the get-go. Sound all right? Okay. So our first example actually gives us the statement where we have steps 1 and 2 already done. So step 1 and 2, turn things into letters and write them in a combined order. And if you notice even like how they draw that line in there, it looks like what we were doing back with Euler diagrams, right? In symbols, it looks like statement, statement, line, statement, but it's written in symbols. Everybody okay so far? Okay, so we've completed, or it's given to us in a completed form for steps 1 and 2. We're on to step 3. Now, what step 3 says we're going to do is we're going to make a conjunction. Conjunction means an and statement. So we're going to make an and statement with the first 2 pieces. And the way that we do that is we join whatever they've been given to us, these 2, and this piece together with an and. Okay, that's it. Yes, sir.
What made us determine that it was an and, not a or?
It's always an and. Yeah, so if you think about it, that's what we were doing. We didn't really verbally sort of identify, but that's what we did with Eulers. We said this one's true and this one's true, therefore this is next.
So because it's set this way, it is that this is true and this is true,
yeah.
Therefore this must be true.
Yeah, and if you think about how people make arguments, this is how you make an argument, right? You talk about this thing happening, and then you talk about this next thing happening, and the process is that both of those things are and, like they both are happening simultaneously. Yeah. Okay. And then we take all of that I just decided, or that I just circled right in the parentheses there, and the circle there, and we make that the premise, the if part of a conditional. So after this thing comes the then part at the end, which for this one is tilde Q. And if it helps you, you can put them in another set of brackets. I'm going to put mine that way. You can do it, you can not do it, but just kind of one more set of grouping symbols that this comes before the then part comes. Okay, so we're always joining the pieces that are at the beginning together with an and statement and making that the beginning of an if-then statement, the one with the arrow, and the part that comes at the bottom, the then part of what comes with the arrow. Okay, so what we're going to do next, step 4, which was very nice and concisely written, is the hardest step because, everything hinges on us doing this, we've already done, but it's the most time-involved step because we're going to create a truth table for this. Okay? Now, the good news on this particular truth table, and it's the only one like this we're going to do today, is that there's only 2 letters, P and Q. Okay, only 2, which means my truth table will only have 2 statements, P and Q. So as I'm setting this up, I'm going to have a column for P and a column for Q. Okay, everybody good so far? And then we're going to work, you can put your tildes all together if you want. Some of my students in the other class really wanted to do that. They wanted to put tilde P and tilde Q next because, they're both there. So if you want to do that, you certainly can. I don't usually do it that way. I usually work from the inside out. So that's the pattern I'm going to continue to follow. But there's nothing wrong with it if you want to do your tildes all next, okay? So feel free if you'd like. So I'm going to work from the inside out, which means inside this first parentheses here. And there is a tilde in there. So the next thing I'm going to do is going to be the tilde P. But then after the tilde P, in terms of the structure, all right, the argument itself, I'm going to do everything that I just highlighted in yellow. So this would be tilde P implies Q. Okay, so I've completed everything in the parentheses, and so I'm now moving out of that. And the next thing is going to be the and P part. So I'm going to create a column. And my column is going to be everything in the brackets. So it's the tilde P implies Q and P. So now I have everything that's in the brackets, or everything that's on the left side of the arrow, right? Everything to the left of the arrow. Now to the right of the arrow, if you haven't already done it, now you need to have the tilde Q column. And then the last thing there is going to be putting all of it together. So we have our tilde P, arrow Q, and P implies tilde Q. You can abbreviate column headers. Careful not to abbreviate them too much. You want to make sure you know what piece you're doing. But if it is something you'd like to try to abbreviate in some way, you can try to do that. Now, with any truth table, this is 2 columns, right? Because we have P and a Q, 2 statements. P and Q columns are going to always look the same. What's the P column going to look like? So 2 of them. So true, true, false, false, right? And then the Q one will alternate. True, false, true, and false. Did I get them in there? Okay, everybody remember that from before? Hope so. The pattern's always the same. Now we're going to build off of that. So what will the tilde P column be? Yeah, it negates or reverses the P column. So false, false, true, true. Okay. Now we're going to do, and this is always the part that I don't like as much, we're going to go backwards. So we're going to go from the tilde P column over to the Q column. We have to be careful because we are moving backwards. Now, you should have seen a video in section 3.3. We talked about if-then statements. And I'm going to reiterate some of the things that you saw from before, because if-then statements cause people the most sort of like discomfort. They don't have a natural feel for them quite the same way. And the example that I gave in the video was my daughter leaving shoes on the floor. Nod your head if you remember my daughter leaving her shoes on the floor. Yeah, that was a year ago. She's still leaving her shoes on the floor, just so you know. Okay, so daughter's shoes on the floor. And here's the way it works. It says something like that. If my daughter leaves her shoes on the floor, do you remember what the then was? Then I take them. And I do. Well, I mean, most of the time. Then I do. That's what we're going to say. Then I do. Okay, so if my daughter leaves her shoes on the floor, then I take them. Okay, so if she leaves her shoes on the floor and I take them, that's a true statement. The true statement follows, then the whole statement would be true, right? Then the rule would hold. Okay? But if my daughter leaves her shoes on the floor and I don't take them, then I'm breaking my own rule, right? That would create a false rule. The rule itself would then be false. Are you with me? Those are the parts that people are usually pretty good with. It's the other ones that aren't good, right? That they get confused on. Well, what happens if your daughter doesn't leave her shoes on the floor? Well, if the daughter doesn't leave her shoes on the floor and I take them, is the rule still a true rule? Presumably so, right? There's nothing that I did that made the rule wrong. If my daughter doesn't leave her shoes on the floor and I don't take them, right? They're still on her feet. Or maybe they actually got to the closet. That'd be kind of a miracle, but pretend. then again, the rule didn't change. The rule is still a true rule. It's a valid rule. So if the first part, if the premise doesn't happen, if she doesn't leave her shoes on the floor, the rule remains true. So anytime you have an if-then statement where the premise, the part in the beginning, is a false premise, then you've got a true rule. Okay? So if it starts out false, the rule is true. So on the first one, we have false implies true. That's a true statement because it doesn't disrupt the rule. Right? If you start out with something that's false, she doesn't leave her shoes on the floor, then who knows what's going to happen? Maybe she got the shoes muddy and I need to wash them. Okay? Or maybe she put them in her room like she was supposed to. Okay? We don't know. Again, the second statement also starts out false. Again, we're moving from right to left, which is a little awkward. So false implies true, false implies false. Both keeps the rule a true rule. The problem comes in later on. So if I have a true implies true, we're good with that one because that works for ands, ors, and if-thens. All that has t's, it's always trues, right? That's not a problem. But this is the one that's the problem, right? True implies false. If you have true implies false, then that breaks the rule, right? And you break the rule enough and it's no longer a rule, right? And this is the problem, right? So if you cannot actually follow through, don't make the rule to start with. So, oops, I'm sorry, that was supposed to say false. Just got carried away. So this is a false one, right? This is where it gets false. Okay, cool. The next one then says that we are supposed to take that column, the tilde P implies Q, this column, and the P column, way back here at the beginning, and join them with an and statement. When is an and statement true? When they're both true, okay? So we're going to go piece by piece. The first one says, I'm just going to move from left to right, true, true, and that is true. The second one is true, true, true. Now, the third row and the fourth row both have false at the beginning, and it's an and statement, which makes them false. Okay. The next one is tilde Q. So tilde Q column just negates or reverses the Q column, right? Q column went true, false, so tilde Q goes false, true, false, true. Lovely. And then the last one actually takes the column here that we created, the tilde P implies Q and P column, and it does an if-then statement into, now we're moving from left to right, into the tilde Q column. Okay? So row 1 says true implies false. What's that one? That's the false one. True implies false is false. Right? That's my daughter leaving her shoes on the floor and me not taking them. I'm breaking my own rule. I have created a false rule if I do that. Now the second one is true implies true. That one is true. Third ones and fourth one both start out false. And if an implication starts out false, it's automatically true. I know, that's the one that feels awkward, okay? Automatically true. And what we do at the end of this is we look at that final column and we ask ourselves, is it a tautology? And the answer here is no. Remember, tautology means they're all trues at the end. This one fails that. And if it is not a tautology, then this is an invalid argument. So this argument's invalid. Now, on the next one, it's actually nice in the fact that it already has this set up for us. You ready to take a look? It's also nice in the fact that there's no tildes. Not that tildes are hard, but they just add more rows, right, or more columns. I mean, I don't have any of those. But it's not nice because it's got 3 premises, right? I have a P, a Q, and an R. So as I'm creating the structure for this, I need to have 3 columns, one for P, one for Q, one for R. And if I have 3 statements, how many rows do I have? Do you remember? 8. That's right. P, Q, and R. Okay, let's get all of our column headers first, and then we'll worry about our rows. All right, so there's no tildes, so we don't even have that discussion. And we're working in parentheses. So what will be our next column header? If P, then Q. So P, arrow Q. P, then Q. There we go. What will be my next column header?
With Q and R.
Yep, it's the next set of parentheses. So Q implies R, or if Q, then R. What would happen next?
Because it's in parentheses, we would go if P then R.
So you certainly can do the P implies R next if you wish. I usually don't, and I'm not going to. Okay, I'm not saying you can't, so write it in if you want. We're gonna have it later if you don't do it now. But I always work on the left-hand side and it's complete till its completion before I move to the right. So what I'm going to do next is I'm going to do everything that's in the brackets on the left. Okay, we did the individual parenthesis parts. So like I've done this piece and I've done this piece, and now I'm going to do all of this. That's what I'm going to do next. Okay, I like to have that come before the next piece. So I'm going to do that in this order. So I've got P implies Q and Q implies R. If you don't do that now, you'll do it next. So you're probably going to reverse the two columns of what I have if you've chosen to do P implies R next. So I am going to do that next then. I'm going to do my P implies R. And then the last column will be the same, whether you reversed my previous two or kept them the same. What will the last column be? Everything. And so I have enough space, so I'm going to write it out, but feel free to just write like all or everything or abbreviate if you would like. P implies Q and Q implies R. Therefore, P implies R. Okay, ready to fill it all in? You bet, no problem. All right, 8 rows. What is column P going to say? You bet. So there's 4 trues. I made this too small in my last class. Let me make it a little bit bigger. All right, what's column Q going to say? True, true, false, false, and then true, true, false, false. How about column R? Alternating, very good. Thank you, William. So we have true, false, all the way down. Okay. Ready to do some arrow statements? That's what's next. All right, so we're going to do P implies Q. So those are my columns, and I'm moving from left to right. So true implies true, which is the first 2 rows, is true. True implies false is my next 2 rows. That's the false one. True implies false is always false. The last 4 rows all start out false, so they're all true. So an implication starting out false automatically makes it a true rule. So 1, 2, 3, and 4 trues at the end. Okay, so the next one is another implication we're going to do. So we're supposed to be doing Q implies R. So here's my Q, and here's my R, and we're going like that, right? Row 1, it's the easy row. True implies true. True, we like that one. Row 2 is true implies false. That's the only false one, okay? Like, that's the only false straight structure. So true implies false is false. Now, the next 2 say false implies true and false implies false. When an implication starts out false, it's automatically true. Right? This is the daughter not leaving the shoes on the floor, so the rule does not get changed no matter what happens next. The rule still holds. All right, the next one is, again, true implies true, so that's true. Then we have true implies false. That's my false one. And then the last 2 start out false, so they're automatically true. Okay. Shifting gears. The next one that I have written down, some of you have P implies R. We'll get to that in a second. But the next one I have written down is an and statement. And it joins P implies Q and Q implies R. When is an and statement true? When they're both true. So I'm going to go row by row. The first one is true, true. That's true. The second one is true and false. False. The third one, false and true. False. The fourth one, false and true. False. Fifth one's true and true. True. Sixth one is true and false. False. Seventh and eighth are true, true. Lots of true at the end. Okay, next is going to be our P implies R. So I've got this one and this one. We're going to go in this order. Back to implications, right? If then. So the first one, true implies true, is true. The next one, true implies false, is false. Then I have true implies true. And then true implies false. False. And then the last four all start out false, which means they are true. Okay, we're almost done. Last column to do. Okay, so our last column, and this is why I did this in the order I did instead of doing the P implies R before, is because I do like, when at all possible, to move from left to right instead of moving from right to left, since that's how we read. And now my lines are like, my columns are set up in that pattern, okay? So we've got P implies Q and Q implies R, implies P implies R. Okay, implication statement. First one is true implies true, is true. Whoops. The next one is false implies false. True. False implies true. True. False implies false. True. All right. Row 5. True implies true. True. False implies true. True. And then rows 7 and 8 are both true, 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 true. So they're trues. Is it a tautology? Yes. What does that mean? It's valid. This is a valid argument. Now, this one and the last one, valid, invalid, it kind of just looks like you're playing with stuff. I get that. But I wanted you to have a feel for the structure of it before we actually do one that has language. And the next one's kind of funny. Are you ready? Let's do it. Okay, we're going to use truth tables to decide if this argument is valid or invalid, and here is the argument. If I were a woman and you were my man, then I'd never stop loving you. I have stopped loving you. Therefore, I am not a woman, or you are not my man. Valentine's Day's coming. It's perfectly timed. There you go. Okay, so this statement feels funny. But besides it feeling funny, it's written in a paragraph, which makes it a little hard to work with. Agreed? So we could write it out like one statement, line, and then another statement. So you could definitely do that, right? If you wanted to, if you felt like that would help you. We're going to think about it that way regardless. The therefore, right there, that's the line. Okay, that's the conclusion we're coming to, and we want to decide if it's a valid conclusion. All right? Now, as you're taking a look at it, if you go back to our list of steps, step number 1 is to turn things into symbols. So can you tell me a simple statement that you see listed here that we need a symbol for? Yep, and we'll take off the word if. So the ifs and thens and ands and ors are all connectives. So the statement's just going to be, I were a woman. And you can play with the verb tenses. It doesn't matter. So if you want to change it to am, is, are, was, were, it doesn't matter. Okay, so it sounds kind of funny to say were a woman. So I'm just going to say that the P, I'm going to use the letter P, is I am a woman. Okay, it just sounds kind of awkward. Okay, I'm a woman. What is another simple statement that you see here? You were my man. And it really does need the my in there. That doesn't make any sense, right? Like you were a man and you were my man. That's different. Agreed? Yeah. Okay, you were, you are, whatever you want. Change your verb tense if you prefer. You were my man. Okay? There is one more statement present here. What is it?
I've stopped loving you.
Yeah, and you can phrase it either way. So you can either say, I've stopped loving you, or you can say, I've never stopped loving you. I'm going to go with what I did in my last class, just so it's consistent. We went with, I've never stopped loving you. Okay, so okay, so these are our three simple statements. Okay, so we remove any of the connectives, and we just take the simple pieces. So we're going to create some symbolic statements of the phrases that are now here. So the first one says, if I were a woman, it's an if-then statement, but it says, and you were my man. So these two are joined together. So that's a P and a Q. If I were a woman and you were my man, right? That's an if part. It's the antecedent. It's the premise of a conditional statement. And what's the conclusion? It's the R. I'd never stop loving you. If you did it like William had said was another option, where it's I stopped loving you, you would write down tilde R. Okay, and that would be perfectly fine. You could do a tilde R there if you phrased your statements that way. It'll all work out in the end. You're just going to have your couple of your things swapped from how I set mine up. Okay? Second sentence says, I've stopped loving you. Okay, what is that in symbols? Tilde R. And again, if we had created the original statement to say, I've stopped loving you, this one would, it would be the other way around, right? We would actually put an R here instead of a tilde R. Therefore, I got the line, right? There's my therefore line. What's next? Well, it says, I am not a woman. Okay, that's tilde P. And then it says, or, right? That's the V. You are not my man. That would be tilde Q. Okay, first identifying the letters. Second, we're making the individual structural statement. And then we're going to go back to what we did right here, where we put them together all in one long line. That's our next step. Okay, so this is step one, kind of. This is step two. Step three is putting it together in a long line. So the way it works is always the same. We take all of this and we join it with and. So we've got P and Q implies R. All of that and tilde R. Joined together with an and. That's everything that I circled in yellow. And then the conclusion to the conditional comes next, which is the part at the beginning, which is the tilde P or tilde Q. Okay, what do we think? This one's harder than the last one, even from this point on, because I have the three statements, but I also now have tildes, right? And I didn't have any negations in the last one when I set it all up. So I'm going to copy this to the next screen, and that's where I'm going to do the truth table for the display. So this is our truth table, symbolic statement all joined together. I'm going to have to write really kind of tight to try to fit it all in here. And I'll do my best to do that. So 3 statements, P, Q, R. If you'll notice, they all have negations coming up later on. So if you wanted to do all the negations in the next 3 column headers, feel free to do so. I'm not going to. I'm still going to work from left to right, inside, outside. That's how I do my truth tables, to keep track of things and to try as much as possible to move from left to right when I have implications. So if I'm looking from left to right and I'm working on the side parentheses, I've got this piece. And the first thing I need to do for this piece is the and part. So I've got P and Q. And then I'm going to have P and Q implies R. Sorry, my lines like to actually connect things when possible, and that doesn't always what I want to do. I'll move it there. Okay. That's everything in yellow. So if I've done everything in yellow, then I'm moving outward from that. I now do have to put my tilde R next, because that's what's coming next, moving from left to right. I have a tilde R. And then after my tilde R, I'm going to have everything in the big giant bracket. So I'm going to have P and Q implies R and tilde R. That has completed the entire left-hand side. We've gotten all of that now. So moving over to the right-hand side, moving from inside out, I need a column for tilde P, and I need a column for tilde Q. Okay, and then what do I need? Yep, the parenthesis, everything that's on the right-hand side. So I need a tilde P or tilde Q. And then what do I have at the end? All of it, and I'm just going to write the word all because it's a really long header if I write it out, and I will be over in that lighter colored screen, and you won't be able to see the white writing. So we'll write it all. Okay, let's crank this guy out. All right, so moving out quickly, we're going to do our best we can because we do have a little bit more after this one. I've got 4 trues, 4 falses. And then I've got 2s, so 2 trues, 2 false, 2 true, 2 false. And then R oscillates, true, false, all the way down. All right, next one. We're going to contain, we're going to get P and we're going to get Q, and we're going to do an and statement. And when is an and statement true? When both are true. That happens on rows 1 and 2. So I have true, true on both of those. Everything else has a false in it. So I've got a bunch of falses. The last 6 in that column are false. And then I'm going to take the P and Q over into the R. This is the one I think that I have to go backwards on because of the structure. So we're going to do P and Q to R. So implication, true implies true is true. True implies false is false. False implies true would be true. And false implies false would be true. In fact, all the last of them are all true because they all start out false. Lots of trues on that row, or that column. Tilde R column. So we're going to flip everything for tilde R. It oscillated true, false, so now it'll oscillate false, true. So false, true, false, true, false, true, false, true. And now we're going to join the P and Q implies R and the tilde R columns with an and when is an and statement true? Both are true. So the first one is false because there's a false there. The second one is false because there's a false there. The third one is false because there's a false there. Finally, row 4 is true, true. Row 5 has a false. Row 6 is true, true. Row 7 has a false. And row 8 is true, true. All right, next one is tilde P. So I'm going to take P and reverse it. So it started out 4 true, 4 false. So now I will have 4 false and then 4 true. I would encourage you to use lined paper if you do this. It'll help you to keep them in row in the lines. Mine get a little wonky on the board. Tilde Q also oscillates, flips it rather. So it went true, true, false, false. So now it will go false, false, true, true, false, false, true, true. And then my last couple of columns here, I'm joining things together from the end. So I have tilde P, tilde Q, and I have an or statement. When is an or statement true? Yeah, when at least one of them is true. So the first one says false, false, so it's false. And then I have false, false, so it's false. And the next one is false, true. There's a true. So then row 4 is false, true, so that's true. 5, 6, 7, and 8 all have at least one true somewhere in them, so they are all true since we have an or statement. Okay, last column takes this massive column here that's in the middle, my P and Q implies R and tilde R column, and it comes all the way over here to the column I just created with the or statement, like this. Now on row 1, 2, and 3, they all start out false, so those are automatically trues. Row 4 is true, true, so that's also true. Row 5 starts out false, so it's true. Row 6 is true, true, so it's true. Row 7 is false, true, so it's true. And row 8 is true, true, so it's true. What does that tell us? It is valid. Okay, now are you ready for a breath of fresh air? Because I think that these truth tables are tedious, especially when there's 3 statements, and the more tildes you have involved, and the more combinations of things. They're very tedious. But there's actually some really nice forms of validity and invalid arguments that we can use. And nobody's asking you here to memorize these, right? Okay, right? We're not memorizing, right? You're just going to have it there with you. These are valid argument forms. There's 4 of them, and there's 2 invalid argument forms. And the reality is that you need to keep in mind that you cannot say something is invalid by a valid form. Neither can you say something is valid by an invalid form. Yeah? It seems like an obvious statement, but I have students do it all the time. They'll say something like, it's valid by fallacy of the inverse. Oh, no, it's not, because it's fallacy. It's one or the other. You can't be both valid and fallacy at the same time. There's one here that's a little different than the rest. You'll notice of the 6 of them, 5 of them say P implies Q. Do you guys see that? 5 of them say that. There's one that doesn't. It's disjunctive syllogism. So the disjunctive syllogism here says P or Q. So when it's P or Q, and then it says tilde P, and then the therefore part at the bottom is Q, it likewise could say tilde Q, and the therefore part here could be P. That is symmetric is the word I want. That's a symmetric statement, okay? So that is another version of how this could show up, and it would be just fine. Here's the cool thing about these, okay? You're going to be given statements like we did back with Euler diagrams, where they're going to be structurally set up with that line and all that. And you're turning them into symbols like we just did with my last example that was kind of funny sounding. But then you're just comparing them to these 6 things, and you're picking which one it matches. That's all you're doing. It's a comparison. So let's do the last 2 really quick. The first one says, if she buys another pair of shoes, her closet will overflow. So she buys another pair of shoes would be one statement. Her closet overflows would be another statement. So this statement is P implies Q. Her closet will overflow. You need to make sure you get the right one. Is that P or is it Q? It is Q. And then I've got my therefore line. And then it says she buys another pair of shoes. That one is P or Q? P. Thank you. Look back at your list of 6 items. Which one does it match? And be careful. The order and the structure of the P's and the Q's matters. Which one is this? It is. This is fallacy of the converse, which means that the argument is invalid. It's a fallacy. It is an invalid argument. So maybe her closet overflowed, but it had nothing to do with buying another pair of shoes, right? Maybe she changed closets. Maybe she got married and now she's forfeited half her closet to somebody else. I don't know, but something else might have happened. It might not have been that she actually bought another pair of shoes. Okay, one more real quick. If Kerry Woods pitches, the Cubs win. So we've got Kerry Woods pitches and the Cubs win. Those are the individual statements. So this is, again, an if-then statement. P implies Q. This then says the Cubs do not win. What is that? It is a tilde, and it is a tilde Q. We want to make sure we get it in the right order. It is tilde Q. There's my therefore line. What is Kerry Woods does not pitch? That is tilde P. So take a look back then. Which one does that match? Good. This is modus tollens. So is it valid or invalid? That is valid. All right. That's it for today.